Money FM 89.3, the best of the afternoon update.
Now, ever wonder what really happens when you type a question into ChatGPT? Behind the scenes, a vast network of servers springs into action, delivering your answer in milliseconds. But all that thinking comes at a hidden cost. Heat, and not just a little. Each rack can churn out as much heat as dozens of ovens working overtime. Now, with the AI boom heating up, literally, data centers are undergoing pressure to keep pace, not just with demand, but also with sustainability expectations. And that's forcing operators to rethink how they cool their facilities and the future of digital infrastructure itself. So what's driving this shift, and could liquid cooling become the norm as data centers race to keep up with Southeast Asia's digital ambitions? We're joined today by Bernardo Jebelli, Director for Thermal Solutions at Vertiv Asia, to help us understand how this trend is reshaping the industry. Bernardo, welcome to the show.
Hi, Lynn. Hi, everyone. Great to be here today. Thanks.
Great to have you with us. You know, Bernardo, some of our listeners might know that on this show, we've previously talked about Southeast Asia's data center boom. But why has cooling, in particular, become such a hot topic? And what's changed in the last few years?
I mean, the point is that, as you mentioned, AI workloads are densifying racks to, let's say, 30, 40, even 100 kilowatts. And compared to the typical 5 or 10 kilowatts just a few years ago, a paradigm shift, that makes everything, the perspective of the industry quite different. So what's happening right now, it's the traditional air cooling simply can't remove that heat anymore. So, I mean, what's happening right now, which is quite significant, is that everyone in the industry is trying to switch from air cooling to other alternatives, which could be some practical. And the best could be a liquid cooling, which we're going to talk about this more today.
All right. Yeah, so it's not just about keeping servers from overheating anymore. It's about making the whole system more efficient and sustainable as well?
Yeah, that's exactly. You raise a very good point. So when we talk about the AI data center, cooling in AI data center, it's not just simply focused, isolated on just cooling. It's just a comprehensive, integrated solution that can be a correlation between cooling and power. And when you design that AI data center, you need to consider all these considerations together to make the system as efficient as possible.
Bernardo, I know you're based here in Singapore. Is this trend unique to Southeast Asia? How does the region's adoption of advanced cooling compare to markets like Europe or North America?
So the thing is that, in Singapore and basically a tropical area, so we are experiencing hot weather, right? Okay, so outdoor temperature is higher than some part of Europe and always some part of America. But the point is when it comes to liquid cooling, so having a cool outdoor temperatures could be quite beneficial and could be quite efficient. However, in Singapore, so we do not have that much that flexibility using the outdoor cold weather to cooling down the data center. That could be a challenge, but that challenge brings us a lot of other opportunities for us to explore other solutions that how we can cool down AI data center with liquid cooling. So, I mean, liquid cooling is the perspective for the future for us for tropical area because water temperature simply is higher, so it could be an option for us in tropical area to cool down data center, considering that the outdoor temperature still is high.
Okay, let's get into that. For listeners who might not be familiar, what exactly is liquid cooling and how does it differ from the traditional air-based systems most data centers use today?
The liquid cooling, simply, if I'm going to make it as simple as possible, is you can imagine the car radiator. So you know that the car radiator, it simply cool down with the recirculation of water in radiator, right? So that's relatively similar to what we have in liquid cooling. In liquid cooling, that instead of pushing the cold air into server, which traditionally was a quite dominant cooling approach, what we're doing right now, we use liquid cooling, meaning that we transfer the liquid directly to the GPU and chips to cool it down. So the heat will dissipate from the CPU to the outdoor with the liquid direct instead of using the air, and that brings a lot of efficiency to the system.
When you say liquid, is it just water or other types of coolants as well?
That liquid could be water, but typically the practice in industry is using the additive of water with other ingredients. So we cannot just simply push the water into the chips because of the different specification reasons. So we usually use other kind of water plus some other additive. That's why we call it a liquid. We don't call it water because it might not be purely water.
Okay, sounds like it's more targeted. And does that mean you can pack more computing power into the same space?
Exactly. Traditionally, when I say traditionally, I'm talking about a few years ago. So we simply talk about 10 kilowatt racks. But right now, talking about 100, 150 kilowatt racks is quite normal and it's quite common practice. Already a lot of hyperscaler and co-location companies already using 100 to 150 kilowatt racks. So that's brings a lot of computing capacity to the racks. But again, the air cooling is not the way to that kind of high density racks. And that's why we are using right now liquid cooling.
I see. And what's driving more operators in Southeast Asia to consider liquid cooling now? Is it purely about keeping up with AI demand?
When we come to the operator know that, first of all, air cooling can handle these high-density racks. Okay, that's the reason why air cannot do that. I mean, again, I'm trying to make it as simple as possible. When you dip down with your finger inside the water, cold water, you can imagine how you feel. And when you put your finger in front of the cold air, simply always water wins in every time. That's why, because water has more heat transfer coefficient, right? So the operator know air cooling at the first time cannot handle that. So on the other side, the operator know that energy cost is quite high. So air cooling, increasing the capacity of air, might be able to handle this, but the point is the energy cost is high. So they're trying to find other alternatives, right? And the other reason that in Southeast Asia, especially, we are encountering a lot of strict rules about the saving power, cut pollution, and all that kind of regulation, right? And all of them are aligned with liquid cooling and not air cooling in AI data centers.
I see. That's interesting. So it's not just about solving a problem, but also future-proofing your facility, I suppose.
Exactly, that's true.
Okay. And when it comes to planning, how feasible is it to retrofit existing facilities for liquid cooling compared to building it into new sites from the ground up?
That's pretty question that you're raising, Lynn. The point is, retrofitting the data center is quite challenging. So the point is, as you know, that a lot of customer, either they retrofit or they try to use the new data center from scratch. And we always in Vertiv do the evaluation whether making a new data center from scratch make more sense technically and price-wise, or retrofitting that existing data center. So let's say we are having the data center, a traditional air cooling data center, and when you want to retrofit this to the liquid cooling, you need to first of all think about a lot of topics that involve here, how to change the racks from the air cool to the liquid cool, and how you're going to add a new infrastructure for liquid cooling. You know, you need a lot of new equipment that you need to add. The system is quite more sensitive in terms of operation. So the people who you work in the liquid cooling data center need to be fully trained. And you simply can bring any contractor to the picture. So you need to bring a trained people to do the liquid cooling system deployment and system setup comparing to air cooling. And so retrofitting comes with a lot of challenges. But when you do evaluation and analysis, you can see you can bring a lot of benefits in a long term, in let's say 5 or 10 years, that makes a lot of players in the market that consider liquid cooling and shifting gradually from air cooling to liquid cooling.
Well, sounds like a very complex process. Let's talk about the industry developments, Bernardo. How is the technology itself evolving in terms of liquid cooling? Are we seeing standardization, or is it still early days?
You know, the driver in the industry, like a GPU and CPU technology provider, you know, a famous one in the market, right? So what they're doing, they're tweaking and changing the capacity of the GPU, and that brings a lot of works on the other side, which we are the supplier and the authority, like policymaker, right? The thing is that usually a policymaker and a standard maker are behind the GPU and supplier. So when they move on and then when they drive a new technology, always we need to chase them and adopt them with the new technology. So we are at work, we always try to offer and propose a new solution with flexibility in future. So we're not trying to catch by surprise. Okay, the new GPU, it's going to be a new capacity, new kind of new technology. No, we usually try to predict these in 5 or 10 years, and we propose and supply something that can take care of all these fluctuations. However, the standard and codes, we cannot expect them to align with the technology as soon as possible. There is always a lag here. Right now, to be honest, we have a lot of limitation on liquid cooling standards and regulation globally, not only in Southeast Asia, but again, we're closely working with policymakers to do a lot of examination, kind of working in facility test lab to do what could be the best standard practice in the future.
Okay, so are we moving past the experimental stage yet and seeing more practical and perhaps scalable options?
I can call right now transition mode. So what we are seeing right now, it's a huge demand on the market to understand what is the best practice. Okay, so what we see right now, a lot of looking for 80% liquid cooling and 20% air cooling. So again, I would like to mention when we talk about liquid cooling is not fully replace the air. It's going to be air cooling, but the bigger portion of the cooling is going to be with liquid cooling. So right now we call it 80 to 20%, but that is not something that we can say everyone should follow. It's based on the project. The project could be different. So right now I call it transition mode. Everyone looking for the best practice. What would be the best practice in terms of the percentage of air to water? What would be the best practice in terms of temperature? What makes the system more sustainable and make more efficient? So right now I can say we are in early deployment time, but the demand is quite high. So I feel that we're going to have a big jump on the next 5 years.
Okay. And what are the biggest challenges that might hold back wider adoption of liquid cooling in this region?
The point is cost. The first and the main point is always the cost.
Okay.
So when we come to the liquid cooling, the upfront cost is much higher than air cooling. So it should make sense, or it should be justified why we are spending more on our system. And that makes sense when you see the operational cost of the liquid cooling system in the long run is much lower than air cooling. So you may pay more at first, but at the end of the day, the 5 or 10 years, your operational costs will save a lot of money, and at the end of the day, the total cost of ownership is lower than air cooling. So the cost could be a barrier, but it makes sense if we go to the detail to understand this could be an investment or it could be just waste of money. The other barrier and challenge we are having here, I just mentioned that the people in liquid cooling need to be really well trained to work. You cannot simply bring anyone who work in HVAC industry to do that. No, it's very sensitive kind of high technology system you need to deploy, so they need to be fully aware of what is the sensitivity of this technology. The other and the most important is the concern about the fluid leakage. You know, it's always when you bring the fluid inside the server, you always have this concern that it might make some leakage and make some downtime. So all of them are challenges which we are solving right now, and I feel quite a bright future for liquid cooling and probably going to be mainstream for cooling AI data center.
Fantastic. And we've touched on sustainability a little bit. So can liquid cooling really help data centers hit their ESG targets?
Yeah, the point is that, like what I mentioned, the liquid cooling is great for environment. So it's not really exaggerating. It's exactly the reason that I'm saying that, because the liquid cooling uses way less power compared to air cooling. So the transition from air cooling to liquid cooling always brings some sort of saving in the cost of electricity. The less electricity, the less power, the less CO2 emission, all that kind of thing is aligned with sustainability, right? So there's not just that. There's a lot of other benefits when it comes to liquid cooling. The point is when the hot water comes back from the data center, you can reuse that hot water. And in a lot of regions, especially in cold climate region, they reuse that heat for other applications. Let's say using the household, let's say using the industrial kind of application. So that reuse of heat, it could be another fix of using the liquid cooling. Also, there are some like kind of new technology which is still in emerging phase, let's say energy cooling or two-phase direct to chip. They're still trying to make some footprint in the industry that even when you compare this kind of emerging technology, they are even more sustainable than liquid cooling. It is a part of liquid cooling, but it's some more advanced technology comparing to the simple liquid cooling. And I believe they are going to be dominant in a very close future.
All right. It really sounds like we're entering a new chapter in how data centers are designed and run, and one where cooling isn't just an afterthought, but, it's quite critical in terms of enabling growth and sustainability as well. Bernardo, thanks so much for joining us today and sharing your insights.
Thanks for having me. Thanks. Great day ahead.
All right, we've been speaking with Bernardo Jebelli, Director for Thermal Solutions at Vertiv Asia, about the rise of liquid cooling in Southeast Asia's data center industry.
To listen to more great interviews, download our podcasts at audio.sg or download the audio app. That's AWEDIO, audio at the App Store and Google Play.